Number 4, we have x squared minus 16 all over 5 times x squared minus x minus 12 all over x squared minus 8x plus 16. Let's factor. Our first fraction numerator, that is the difference of two squares. So we have x plus 4 times x minus 4 all over 5 times, let's look at the second fraction numerator. We're saying what a factors of negative 12 that would add to give us negative 1. And with those binomials, the signs are going to be different. X and x for the first term, plus minus. So let's find factors. We have 4 and 3. We want the 4 to be negative, and we want the 3 to be positive. So 3 is positive, 4 is negative. And then our denominator, this is a perfect square trinomial where the binomials are identical. We have x minus 4 times x minus 4. And then let's cancel. We have two sets of x minus 4s. And there's nothing else that we can cancel out. Therefore, our numerator we have left x plus 4 times x plus 3 all over 5. Question 5. We have 3x cubed minus 81 all over 6x squared plus 6x minus 72 times 4x plus 28 all over 2x squared plus 6x plus 18. So let's look at the first fraction, the binomial. Look at that power. It's a 3. So that means we're going to be using the cubes pattern. So if you remember back in the previous set of modules, we talked about difference of cubes and how our answer should look. We have a binomial times a trinomial. So we're going to keep this in front of us as we find the solution to the 3x cubed minus 81 as we factor. But before we use the pattern, is there a GCF that can be factored out? If so, what? We can factor out a 3. So I'm going to use another sheet of paper just so I can show you the factoring process. So remember the difference of two cubes. Here's the pattern. Here's the question again. 3x cubed minus 81. There is a GCF that can be factored out. That's 3. And then we have left over x cubed minus 27. So this is the part we want to factor, the x cubed minus 27. So we need to, let's look at x cubed and the 27. We need to find the factor. What will be that number that when we cube it will give us x cubed, and then as well as the 27. So the number that we're going to plug in, when we cube it gives us x cubed, that will be an x. And what number when we cube it, meaning multiplying it 3 times to give us 27, that will be 3. So as we write our solution to this difference of cubes, it says for the binomial part, we're going to subtract f and l. So we called f the variable x, we call l the number 3. So we have here x minus 3 times. Then it says square the first term. So we're going to square x. We have x squared. Take the opposite sign, positive. Then it says we're going to multiply f and l. So x times 3 gives us 3x plus, and then we're going to square L, meaning square 3. 3 times 3, we have 9. So now we have the solution to that cube, the difference of cubes. That's what we're using. So let's go ahead and write that out. That was the side work to this example. So here's our numerator, 3 times x minus 3 times x squared minus 3x plus 9 all over, and then um, before we look at that denominator, look at this x squared minus 3x plus 9. Whenever we use the difference of two cubes pattern as well as the sum of two cubes pattern, the factoring method, that trinomial cannot be factored. Because think about it, what are factors of 9 that will add to give you 3? Factors of 9, 1 and 3, 3 and 3. We add those together, we will have a 10, and then we will have a 6. So this trinomial can't be factored at all. But let's take a look at our denominator. We can factor out a 6. So we're going to factor out a 6, and we have x squared plus x minus 12. That's a two-parter there. So now we're looking for factors of 12. What are factors of 12? Negative 12. That will add to give you positive 1. So set up your template. Don't forget about the 6 that we factored out. X and X, signs are opposite. So we're going to be using 4 and 3. And we would want the 4 to be positive and the 3 to be negative. Times, and we're finished with that trinomial. Second fraction, we're going to factor out a GCF, which we have a 4, and that gives us x plus what? 7. And then look at the denominator. There, we're going to factor out a 2. And you have 2 times x squared plus 3x plus 9. Now, look at the x squared plus 3x plus 9. Okay, I see a mistake that I did, and I'm pretty sure you may recognize it. I'll say it in a few seconds. So remember, what are factors of 9 that would give us 3? It doesn't work out. So this denominator is going to be 2 times x squared plus 3x plus 9. So let's go back to this, the first fraction numerator. I didn't transfer my information correctly. This sign here should have been a plus. So if you notice that, great. Being able to identify and say, hey, this is not right. Ms. Lewis said that the signs are supposed to be opposite of the binomial, and I didn't write it. So now it's correct. So let's cancel. We can cancel out the x minus 3's, the x squared plus 3x plus 9. Anything else that we can cancel out? Well, look at your numbers. I just want you to see something. Let's multiply what we have left in the numerator. We have a 3 and a 4 in the numerator. We're going to multiply those together. That gives us 12 times we have x plus 7. And then in the denominator, we have a 6 and a 2. We're going to multiply those together. That gives us 12 all over x plus 4. And what divides out? The 12s. And then our answer is x plus 7 over x plus 4.